Okay, class, I'm going to give you today's lesson since I'm not there, but I'll record this ahead of time so that you can take notes and be able to do your homework like we haven't missed a day. So we're on to Lesson 5, Compound Boolean Expressions, which is nice because we can start using the ands and the ors and the nots. So our objectives today are to get the meaning of those Boolean operators and then write some programs. We really won't write programs today, but probably read programs that use Boolean operators. And then we're going to learn about truth tables. Now, some of you don't know much about truth tables, so you might have to go slow through that part. And some of you already know, so you can speed through there. But you can use truth tables to determine when expressions are true or false. Okay. So let's start. Boolean data types can only take on two values, a true and a false. A lot of times it's a 1 and 0 or something like that, you know. Give me true, false, 1, 0 with computers. Okay, so let's look at how we declare a Boolean. You already know that. We have Boolean failed equals true. So you just assign a variable. In this case, the variable would be called failed. All right? And then when you want to talk about that variable, if you want to put it in a conditional, if you say if failed, all right, well, that means if failed is true. That's like a shorthand, okay? It's a shorthand for failed is true. Now, how you would write not failed, how would you say it if you wanted it to be false? You could say if failed equals false, or you could say if not failed. Either one would give you the right thing. All right, so let's talk about the Boolean operators. We have and it's these two ampersand signs, which I'm just going to tell you right now, I can't write those, so I always do these, like these little E's. Those are my ampersands. And then we have the or, which is like two parallel lines, and then not, you already learned, is a exclamation point. So Booleans are primitive data, so you can assign one to the other. So this is just an example. If I assign a variable test1, the variable value true, then I can take another variable that I declare as Boolean and copy what the value of test1 is into test2. So nothing surprising there. We can also set variables equal to condition. So if I have already, of course, declared test1, so I already made it. Now I'm going to change it. So that's why I don't have the Boolean out in front, because I've already declared it. But I can evaluate 2 plus 2, which is 4, and then equals 4. And 4 does equal 4. So test 1 would get the value true. And then test 2, I can make 3 times 100. So I'll do that first. That would be 300. And 300 is not less than 250. So that would be false. So test 2 would be given the variable false. Now, I say here that you don't need parentheses, but they do make the statement a little more readable. You can decide whether or not you want to do that. Just don't go crazy with parentheses everywhere. Try to figure out when they really are necessary. Okay, now for all of you who haven't done truth tables before, I'm going to show you the 3 basic truth tables, and then we'll do some bigger truth tables after that. So the first 3 are, first of all, let's get the not truth table. So what we have, and we'll use like variable A and not A. It's a very simple truth table. Now, you would say the possibilities of A could be true or false. There's only 2 possibilities. It's because we're using, conditionals where it only has 2 values, true or false. And so if it's not A, of course this would be false and this would be true. So that's the first truth table and the negation. Now, the second one we're going to do is A or B, the or. All right, so we need two variables this time, and we have to set up all the possibilities for what each one can have, every possibility. So how we do it is true, true, false, false for the first variable, and then true, false, every other for the second. Now watch, this makes it so you have every possibility. Both are true. First one's true, the second one's false. First one's false, the second one's true, and both are false. So this just sets up every possible value of true and false for A and B. And now, or means one or both are true equals true. Okay, one or both. So for the first line, we have true and true, so they're both true, so that's true. Second line, we have true or false. We have a true and a false, and so we have one true, so it's still true. Third line, we have false and true, so we still have one true, so it's true. And then the fourth line, we have false and false, so there's no true at all, so that has to be a false for or. So or is true, 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 false, only false when both are false. And the third one is A and B. Okay, it's an and. So we set up the same way, A, B, and now this time we have A and B. Okay, and we are going to set it up the same way, all possibilities, true, true, false, false, true, false, true, false. And then we have, okay, so the rule for, this was the rule for or, the rule for and is both must be true for true. Okay, so true, true, so this one is true. But anywhere we have a false, so line 1 was true, but then we have a true and a false, so that has to be false. A false and a true, so that has to be false. And a false and a false, so that's false. So we only have one true and an and if we just have two variables. Okay, and let me do one more thing on this page. Let's use logic to show how we can use the Boolean instead of nested ifs. So here's an example. We're going to say if num is greater than or equal to 1, we're going to do it if num is greater than or equal to 1 or less than or equal to 10, okay? So just something we're needing to see if it's between 1 and 10, inclusive. So we would say if num is greater than or equal to 1, that's your first, and this is what you've been doing. And then nested in there, you say if num is less than or equal to 10. And then if it is, you do some statement. And then you have to close it out and close it out. Okay, so if we want to write it using a Boolean algebra, we just need one line. We can say if num is greater than or equal to 1 and, because it has to fit both things, it has to be true for both things, num is less than or equal to 10, then we're done, statement. So we've combined those two things together using an and using our rules. They both have to be true. And so it's a quicker way without doing nested ifs. So it's not so bad. Okay. So this is using, let's see, let me use green, using ifs and using Boolean logic. Okay, so I'm going to stop this first video there. There'll be a second or third one too.